Okay, so we're going to look at problem solving with, oh, I meant to write in right angle triangles here. Okay. We have our primary trig ratio, and I've highlighted the letters to help you guys remember our acronym so that we can keep in mind what these formulas are. SO stands for sine theta is equal to opposite over hypotenuse, so SOH. Ca is cosine theta is equal to adjacent over hypotenuse, so that's CAH. And TOA is tan theta is equal to opposite over adjacent. So, let's keep these in mind. We're going to have to build our question. The question says, 81 meters from the base of a building, the angle of elevation is 50 degrees. So let's create this situation. Here's our building. And we are 81 meters from the base of the building. So the base of the building would be the bottom. And we assume that the ground and the building themselves are 90 degrees from each other. They create a right angle. Okay? This distance is 81 meters. And we know the angle of elevation to the top of the building is 50 degrees. So this angle here is 50 degrees. I didn't write in what the question was. But let's say we want to figure out, and we'll do two different ways. Let's say we want to figure out what the height of the building is. So what is h in this case? Okay. We are going to set up our primary trig ratios, and we're going to set up all three of them to see which one will help us solve this, which one we have enough info for. So whenever we talk about sine, cos, and theta, we're talking about our angle. We're in reference to a specific angle. Okay? Now this angle here, our 50 degrees, is the one we're going to be talking about. We're not going to focus on 90 when we're using SOHCAHTOA. Though we know we can, we'll keep it easy by doing this. So sine theta, theta in this case is our 50 degrees. So sine theta is equal to opposite. Which side would be opposite? Is equal to h over, what is the last part of this formula? Over what? Let's go up and see what they stand for. What's OH stand for? Opposite over hypotenuse. Do we know how long the hypotenuse is? No, we'll call it x. So in this case, it's x. So the information we can fill in is we can fill in theta. We know it's 50 degrees. Do we know h or x? No. I don't have enough information to solve this using sine. I have two variables. I need at least one other piece of information to do this. So let's try cos. Cos 50 is equal to, what does cos stand for? Adjacent over hypotenuse. So the adjacent is 81. Great. So we have 81 over, what's the hypotenuse? X. Great. Do I have enough information to solve for what I was looking for? Yes. What was I looking for?
Oh, never mind.
I'm looking for the height. Is the height even involved in this question? No, the height's not even involved. So this doesn't technically solve what we're looking for. So let's go to our last one here. Tan 50 is O over A, which is opposite, which is the height, okay, which is equal to our adjacent. What is our adjacent measurement? 81. In this one, I have 2 out of the 3 pieces here, and h is what we're looking for. So I'm able to solve for h. This is a pretty easy step from here. I'm going to move this formula over. Right. The goal is to isolate for h. So to isolate for h, what do I need to move to the other side? And what operation on the other side? Great. So we have 80 times 50. Oh, sorry, it is 81. Times 1050 is equal to h. So we'll take out our calculator here. And we have 50, 10, probably is, times 81. 96.5. Thank you for being so accommodating. 96.5, and I think we're in meters here, right? So the height of this building is 96.5. Great. Now that we have this information, 96.5 meters, So the height of the building is relatively high. Let's say we wanted to find the distance from where you were standing to the top of the building. What part of the triangle would we be looking for? Hypotenuse. What formula can we use to solve this? That's right. Cos is already set up for us. Cos would allow us to find the hypotenuse. Now, we did get another piece of information. Because we now have the two legs, we can use Pythagorean's theorem to also solve it. But since we've already set up cos, let's go through it that way. Both will give us the answer. So let's go with cos. And this one we'll use because it is going to be a little different. Cos 50 is equal to 81 over x. Now we need to isolate for x in this case. Okay. So how do we isolate for x when x is on the bottom of a fraction? Okay, so let's do the same thing. What did we move last time? We moved the bottom of the fraction, so I'll move the bottom of the fraction, which is x. If we move x to the other side, what operation will we use? Multiplication. So we have x times cos 50 equals 81. Is x by itself yet? No? That's right. I can move cos 50 to the other side. Now, I don't use the inverse here because I'm moving all of cos 50. And this is technically multiplication. So to move cos 50 to the other side, what operation do we use? Use division. This becomes 81 over cos 50. Remember, cos 50 is some value. We don't exactly know what it is. So this would become x is equal to 81 over cos 50. And we can actually find a value for cos 50. Let's see. 50 cos. Is this large number here? Okay. I got an answer button here. Not quite. So let's write that in. 0.642. 81 over 0.642. Sorry, you can. So the calculator I have is a little more difficult to do this, but on many of your calculators you can do this step. You can type that all in one shot. And this one here for me, I'd actually have to go 81 divided by bracket 50 cos end bracket equals, and it's kind of written on top here. So it looks like 81 divided by cos 50. And then this would be our final answer, 126. 126 meters. Does that make sense in reference to the other angles?
Yeah.
Why? And what does the hypotenuse always have to be? It's got to be the longest side if we're dealing with a right angle triangle.